Okay, so let's learn about the Amazon Elastic Compute Cloud EC2. So with EC2, you're running what we call instances. So an instance is kind of like a virtual server or a virtual machine running on AWS. Now, there are physical servers, of course, which run the virtualization platform on which your instances are launched. But all of that is managed for you. So that's all managed by AWS. So this is called Infrastructure as a Service, IaaS, which we learned about earlier in the course. Now, each instance is essentially like a virtual machine, which we learned about earlier in the course as well. So it will have a certain amount of CPU, RAM, drive space, and network interface bandwidth assigned to it. And it will then have an operating system, and then it can have some applications which you install. So the operating system will be Windows or Linux. So think of an EC2 instance as a virtual server, so very similar to when we were looking at virtual machines. So you can choose multiple flavors of Windows or Linux operating systems to run your EC2 instances. Now, an EC2 instance will need an IP address. So there are 3 different types of IP address that your instance can obtain. Firstly, you have a public IP address. So if your instance is in a public subnet, it can get a public IP address. Now that literally just means it's an IP address which you can route across the internet. So you can have it appearing on the internet, you can connect to it on the internet. So if you have a website, for example, you might want to be able to connect directly to your website using its IP address. Now you don't get charged for a public IP address, but it's important to note that when you stop your instance and start it again, you're going to get a new public IP address. So you can't rely on it being the same address. They're also associated with a private address on the instance, and they can't be moved between different instances. Now, I'll explain more about that in a moment. EC2 instances always have a private IP address, and this is basically an IP address from a range which is only used internally, so it's reserved for internal use. These are retained when the instance is stopped, so it will have the same address when it started again. And it doesn't matter whether you're in a public or private subnet, your instance will always have one. And then lastly, we have what's called an elastic IP address. Now, this is basically the same as a public IP address in that it is a publicly routable IP address, but it's static. So that means when you stop your instance, it doesn't get lost like with the public IP. Now, you don't get charged while you're using it, but if it's associated to your account but you're not using it, then you do get charged. And that's because AWS want to kind of incentivize you to make sure that you use these properly, because public IP version 4 addresses are in scarce supply for the internet. And just like the public address, it actually gets associated to a private address on your instance. Now, you can move these between instances, so between the network cards that are attached to the instances, which in the AWS world are known as elastic network adapters. That means, for instance, you can mask the failure of an instance by moving its IP address to another running instance. Let's now have a quick look at the subnets and how we connect from our subnets to the internet. So firstly, we have public subnets. In this case, we have a public IP or an elastic IP, so a public IP address attached to our instance. And we have an internet gateway. And so our way out to the internet is via the internet gateway. And that means that in our public subnet route table, we must have this entry that says, that's all addresses and the target is the internet gateway. So that means anything that's not in the internal range is going to go out via the internet gateway. So that's what we want to be able to send traffic to the internet. Now, what if you have a private subnet? Well, in that case, the instances in a private subnet only have private IP addresses, and you can't connect to an internet gateway with a private IP. So you use something called a network address translation gateway, a NAT gateway. And this is something you can create in your AWS account. And in this instance, the different subnets have their own route tables. So the private subnet route table has a entry which says, for all traffic outside of the local range, send it to the NAT gateway ID. And the NAT gateway is actually in a public subnet, and it knows that it can send traffic to the internet gateway. So what it does, it receives traffic using private IP addresses and then forwards it on using elastic IP addresses, so a public routable IP address. So that's quickly how those two things work. We will be mostly using public subnets for this course, but if you do want to use private subnets, then if you want those instances to be able to connect outbound to the internet, you'll need to implement a NAT gateway. So just remember, NAT equals network address translation, and that's how you can allow your instances in private subnets to connect to the internet.